Today we look at rate of change and slope, and we're going to see how those are tied together. And for what we're doing in algebra, that kind of means the same thing. And so rate of change being some values that stay constant. When that value stays constant, then you're going to see that we're dealing with slope, and then that leads us into linear equations. So you can see how chapter 2 kind of is starting to tie into that. We're on page 76 in your book, so we're going to be able to find the rate of change today and then use that or use a little formula to find the slope of a line. Let's just jump on in to example 1. And it says that this table right here on 76 shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in the temperature for the solution. Now, when you do this, we can really use any of these ordered pair from this table. I'm going to use the two the book uses. So the book says, hey, based on this data, one of our ordered pairs is 2. Now, if you'll notice that x is time in minutes, that's our independent variable. Time is usually independent. And then at 2 minutes, all right, the temperature, all right, is 139.4. So there's one ordered pair. And we could graph that and look at it on a graph, but that's what ordered pair are. They're going to make up some sort of relation or function. The other ordered pair they give us, or that they look at, is 5 and then 133.1. Now, you can do rate of change between any 2 points that you take from a table or any 2 points you take from a graph. I would say normally that what you need to be able to do is pick something that's going to work out easy for you. In this instance, if this doesn't work out, then it's no big deal. That it's nice and easy. We'll let the calculator do it for us. All right, so here's kind of what's going on. When we're going to find the rate of change, we have a little formula. And the rate of change is going to be this. It's going to be the change in y, or what the y is changed by, divided by the change in the x's, or what the x's changed by. Okay, another way to say this, math notation, is delta y over delta x. That's the rate, all right, to find, are we going to end up, is it going to be constant, which may lead us, or which is going to lead us to linear, all right? So we're just going to plug in, what do our y's change by? All right, when we set this up, we will generally take the second y and then from the first y, and the second x from the first x, so you can see in the book what's going on here. All right, so we're going to plug it in. So I'm going to take my second y, which is 133.1, and I'm going to subtract the first y, 139.4. I'm going to divide that by the second x, 5, minus the first x, 2. So what we really did right here is we kind of labeled these. That first parenthesis was x1 and y1. That second parenthesis was x2 and y2. If you know anything about the slope formula, we just kind of gave you what the slope formula is, but we'll get there in a second. All right, we'll keep doing this math right here. If you're not good at it, that's fine, but 133.1 minus 139.4 is negative 6.3. Divided by 5 minus 2 is 3. This actually divides in there nice and easy. Negative 6.3 divided by 3 is negative 2.1. So we just showed what the rate of change is. Now, here's what that means for the problem. That means every minute that oil or whatever that liquid is sits, it's decreasing by a temperature of negative 2.1, or it's going down. So decreasing, going down, that's our answer right there. That's the rate of change to solve this. Obviously, when the numbers in the table are going down, we're thinking that our rate of change is going to go down or be negative. On this problem, we're not going to do guided practice 1, but the rate of change is going up. We're expecting a positive answer there, all right? So rate of change and slope mean the same thing, all right? So we got to be able to get that data from a table. Let's keep going. Let's go to example 2 on the next page. That's page 77. Here's what it says. It says, refer to this graph at the right. Find the average rate of change of the sales for both digital music and ebooks from 2004 to 2009, and we're going to compare those rates. All right, so let's look at digital music first. You can kind of see from this graph the digital music is that red bar. You probably know that that's going up a little bit higher from 04 to 09 than people buying ebooks. All right, we kind of see. Now notice this out here represents millions of dollars. All right, so at 0, that's 0 million. Well, up here, that's 500 million. So this gets into a billion, 1.5 billion. I mean, that's how it goes. That doesn't really matter here. Just understand what we're talking about. Our independent here, or our x, is time in years. All right, so here we go. Our little formula is going to be delta y over delta x. For this problem, the change in the sales price, or how much money is made, or the change in that, divided by the change in time, or the years. So we're going to pick 2 points, all right, and we're going to do this. Since it said from 04 to 09, then let's set those up. So in 2009, what's our digital music sales? We're at 3,100 on this graph. Remember, that's $3.1 billion for this data. So there's my X, all right? My Y, that's I wrote that wrong. My X is 2009. My Y is 3,100. Make sure to make that change. All right, again, it's 2009. My other ordered pair that I'm going to use here is in the year 2004. All right, digital sales was at 200 million. Okay, so that's where we're at. So again, get this change right here. But I've got year, I've got sales in millions of dollars, year, sales in millions of dollars. Now we're going to go set up our little fraction, change in Y over change in X. Okay, now you can set this up either way, and I'm going to do it the way the book set it up. 3,100 minus 200, and that's divided by 2009 minus 2004. Now, if you'd have done this the other way, notice kind of how we plug this in. We actually call this X1 and Y1, and this one X2 and Y2. It doesn't matter how you do it. If you flip-flop those, you'll get 2 negative numbers, which will still be a positive, because a negative divided by a negative is a positive. I keep doing this math. So on the top, 3,100 minus 200 is 2,900, divided by 2009 minus 2004. That's a difference of 5 years. We can go ahead and divide that in the calculator, and we get 580. Now, what that represents is, in that 5-year span, that we're selling $580 million worth of digital music, because, again, our Y's were represented as millions of dollars. All right, let's go look at ebooks. So that was dealing with digital. Ebooks down here, delta Y over delta X. All right, so I'm going to do the same years. All right, I'm going to set it up the other way this time just so you can see it doesn't really matter. So we're going to do in 2004, let's see what our sales were. Well, our sales right there were $9.6 million in ebooks. Not quite as much as digital, but it gets even worse. It gets even bigger. Coming here in 2009, the reason I'm putting the year first, time, is our independent variable. It is the X. All right, in 2009, we were $165.8 million in sales for ebooks. All right, let's go set it up. Again, if you want to call this X1, Y1, X2, Y2, if you flip-flop it, it's fine. We have growth here. We're expecting a positive answer. All right, so here we go. So I've got 165.8 minus 9.6 divided by 2009 minus 2004. All right, let the calculator help you out here. I'm just going with what the book says. The book says the top is 156.2 divided by our same 5-year total from earlier. It should be the same. It's the same time frame that we're looking at. I divide those. Book says that's 31.24. So just compare the sales here. Between those 5 years, average sales of ebooks is just a little over 31 million. All right. The average sale of digital music was nearly 600 million a year. There you go, all you iPod people. Oh, y'all don't have iPods anymore, do you? Okay. Right. Digital music grew quite a bit more than ebook sales. All right. So what we're going to jump down into, kind of bottom of page 77, starts talking about how slope applies. Now you can always do slope as rise over run. When you do that, we go from left point to right point. We're not going to quite do it like that today. We're going to go ahead and use this slope formula at the bottom of 77. So that's what I'm referring to. We're going to flip the page, and we're going to keep going. So we're on page 78. Again, the formula shows up again if you're needing the slope of a line. All right, we're jumping into example 3. But the formula for slope of a line, remember in algebra, slope is notated as m. And m is going to be y2 minus y1 over x2 minus x1. Notice it's a minus sign in between both your numerator and your denominator. All right, example 3 says this. Find the slope of the line that passes through the point -4, 3, and 2, 5. All right? So let's just plug it in and solve it. If you want to label these, we can call this x1 and y1, x2 and y2. You can call this x2, y2, and this x1, y1. Just be consistent. Find you a pattern that's right and do it. So let's go plug into the formula. My formula says we have y2, which is 5. The formula says minus y1 is 3. Okay, keep going. Go to the denominator. X2 is 2. The formula has a minus. Now notice this. X1 is negative 4. So when I plug a negative in, I have minus a negative. That's not incorrect. That's how we set it up. But now we got to know what to do with that. So let's do some math. On the top, 5 minus 3 is 2. Now on the bottom, remember, minus a negative becomes a positive. All right? I don't know exactly how you learn. I've heard several different things. All right? I like to make minus a negative a big plus sign. On the bottom, 2 plus 4 is 6. We always reduce fractions in here. 2 over 6 reduces to 1/3. There's your slope. All right? There's your slope. Should be in pretty good shape. One thing I want to draw your attention to now, and you're not necessarily going to see it right this second, but you're going to see it pretty soon. If you ever get 0 on top, if you're doing the math in the numerator of the slope formula and you get 0, that's fine. Your slope is 0. But if you ever get 0 in the denominator when those x's were the same, that means we had a vertical line, and that slope is called undefined. We're going to be hitting on that, but that's just kind of the precursor intro to that. All right, let's jump down to example 4. This is going to be my last one. This is pretty easy. So now it's finding slope from a line. You can do this just by doing rise over run. I'm going to show you how to do it using slope formula because rise over run is something that's pretty simple, and I want to make sure we're good with our slope formula. Again, m equals y2 minus y1 over x2 minus x1. You don't need to memorize that because you're going to be able to use notes on a test or anything like that. All right, so when we're doing this from a graph, I need to find where the line intersects the grid. Okay, so you can see like right there at -2, 0, that's one of the points where the line intersects the grid. All right, I'm going to come and look at my other intercept, see if it's good. It is. 0, -3, you see it right there? So 0, -3 is another place where the line crosses the grid. Don't pick ones that aren't even because it's going to be a little bit tougher to tell. I'm not saying never to do it. I'm saying if there are nice whole number answers for ordered pair, let's use those. All right, here we go. I got x1, y1. I got x2, y2. Let's plug it in and solve. y2 is -3 minus y1 is 0. x2 is 0 minus x1 is -2. There's minus a negative again. Keep doing the math. -3 minus 0 stays -3. Remember, minus a negative in the denominator becomes a positive. 0 plus 2 is 2. I don't need to reduce that. I can leave the negative where it is, or I can write it out front as -3/2. Either one of those are right. You just need to understand my rise over run right there was down 3, right 2. I like doing it this way because then, if it gives you a negative in the numerator, you know that your rise is actually down, and that way it will always leave your run going to the right, and you can see we have negative slope. In 4A right here, guided practice, we're expecting positive slope. Now, if I'm doing rise over run, you can try to pick points that intersect the grid. You just got to be careful as to what they're counting by. Notice in this one, they're counting by 2s. So make sure you pay attention to the unit measures. 4B would be negative slope. You can do rise over run, that's fine. Make sure you can pick 2 ordered pair out from a graph and use slope formula on that. So this is just kind of the intro to linears. We're getting a real good feel for it. If you're having any questions, you need to come see me. Make sure you're getting all of these things copied down in your notes, just the way I'm doing them. If you ever need extra examples, there's extra examples in the book. You can copy down some of your problems for ConnectEd or ALEKS or anything you need to make your notes as successful as you can make them.